Hello students, good evening to all of you. Today we will study the next problem based on the empirical formula and molecular formula. Let's see the statement of the problem. An organic compound having the molecular mass 60 is found to contain carbon 20%, hydrogen 6.67% and nitrogen 46.67%, while the rest is oxygen. On heating, it gives NH3 along with solid residue. The solid residue gives violet color with alkaline copper sulfate solution. The compound is A option NH2CO NH2, B CS3NCO, C CS3CO NH5 and D CS3CH2CO NH2. So students, we will solve this problem based on the percentage. Here percentage composition is given. Based on this one we will calculate the molecular formula, because here molecular formula is given. So we will compare which option is the correct. So first we have to calculate the percentage of oxygen, because percentage of carbon given, hydrogen given and nitrogen given, but the percentage of oxygen not given. So already I calculated students. See, percentage of oxygen equal to 100 minus percentage of carbon, percentage of this hydrogen, percentage of nitrogen. So it comes 26.66%. For calculation of the empirical formula or molecular formula, we need to learn this table. Okay. So here we'll write the elements. This table consists of the 6 columns. Already I informed to you in many of the videos. Elements, first write the how many elements are present in this compound: carbon, hydrogen, nitrogen, oxygen. What is the percentage of carbon? We'll write here 20%. What is the percentage of hydrogen? 6.67%. And what is the percentage of nitrogen? 46.67%. And percentage of oxygen is 26.66. Okay. Now we'll write the atomic mass of carbon 12, atomic mass of hydrogen 1, atomic mass of nitrogen equal to 14, and atomic mass of the oxygen is 16. Now we will calculate the moles of atom. So for calculation of moles of atom, we know the formula: mass of atom divided by atomic mass. So this percentage composition will act as the this percentage will act as the mass of the carbon. So it will be equal to mass of carbon 20 divided by 12. Here mass of hydrogen equal to, if you are going to divide, you will get after division 1.66. Already I calculated rough work. Okay. Here we will calculate the moles of hydrogen. Mass of hydrogen 6.67 divided by 1 is the atomic mass of hydrogen equal to 6.67. Moles of nitrogen equal to 46.67 divided by atomic mass of nitrogen equal to 14, equal to, after division you will get, that is the 3.33. And this is the, now we will calculate the finally moles of oxygen. So mass of oxygen, that is the percentage of oxygen divided by atomic mass of oxygen, we will get, that is 1.66. Okay. So up to no problem, I think. Now we will calculate the mole ratio. For the calculation of mole ratio, we will see out of all the moles which is the smaller one. So 1.6 is the smaller one. We will divide all the moles with this smaller value. Okay. Here we are having the both 1.66. So you can divide it. Okay. So we will divide all the moles by 1.66 so that we can get the mole ratio. So 1.66 divided by 1.66 will get 1. 6.67 divided by 1.66 equal to 4. And 3.33 divided by 1.66 will get the mole ratio equal to 2. 1.66 divided by 1.66 will get 1. These mole ratio will act as the simple whole number ratio. So 1, 4, 2, 1. Now, by using this simplest whole number ratio, we'll able to find out the empirical formula. So, empirical formula equal to the, how many carbons are there? C1, C1, N, C1, H4. So, H4, N2, N2, O1. So, O1. Or it will be CH4, N2O. If you are going to arrange this equation, you will get some arrangement. But before arranging, we will see what is the molecular mass of empirical formula. So here empirical formula. So here how many carbons are there? 1 carbon is there. 12 plus 4 into 1. 4 hydrogen times 1 plus 2 nitrogen. 2 nitrogen 1 plus 1 oxygen is there. Okay. By adding you will get 60. By adding you will get the answer 60. So molecular mass of empirical formula or empirical formula mass we got 60 gram. Okay. Now we will use this data for the calculation of molecular formula. So students, let's see. Molecular formula equal to N into empirical formula. Now we'll calculate the N. Molecular mass, N equal to N equal to molecular mass upon empirical formula mass. So molecular mass or molar mass is given in the question 60, and empirical formula mass we calculated, it also comes 60. So we'll divide, we'll get N equal to 1. We'll put the value here 1 into CH4 N2O. So if you are going to find out, it will come molecular formula equal to NH2CO NH2. You can rearrange it. Here CH4 N2O is there. Okay. You'll see that is C, 1 carbon is there, 4 hydrogen are there. So 2 hydrogen here and 2 hydrogen, 4 hydrogen are there. And 2 nitrogen, 1 nitrogen is here and 1 nitrogen is here. And 1 oxygen is there, 1 oxygen. So this is the molecular formula of the compound. Okay. So hope you got the concept. So this is the answer, students. Thank you. Have a good day. But here if you are going, here A is the correct option. Okay. NH2CO, NH2. When you are going to heat, you will get the NH3 and other reaction will take place in the A. Okay. So hope you got the concept. Thank you. Have a good day.